Hey there, I'm Kunal and welcome back. In today's video, we're going to talk about how to tackle observational studies and experiments questions on the SAT math section. First, let's go over some definitions relating to this topic, starting off with observational studies. Now, observational studies are where we gather data and conduct surveys on individuals within some kind of sample without actually influencing them. So we're simply watching them from afar and understanding patterns from the data that we've collected or previously collected data. Now, controlled experiments are going to take this one step further and try and find causation. So what we would do is we would assign individuals into groups and give one group a treatment and not give that same treatment to another group. And then we're going to compare the results from the groups and see if the treatment made any difference. So let's take a look at a couple of examples so we can further understand the difference between controlled experiments and observational studies. So let's start off with looking at some examples of controlled experiments. So this first one is where you split a sample into two groups. You would give one group a new medicine and the second group a placebo and see differences. So this is like if we made a new medicine and want to see if it can help cure an illness. You would take people with that illness and you would give some of them the actual medicine you made and some of them a placebo drug to see if there are any differences and if your new medicine is actually working. And then another example is you split a sample into two groups. You would instruct one to drink coffee every day and then the other to not drink coffee so you can compare their sleep patterns. Because there are a lot of people who believe that if you drink coffee or caffeine and things like that, it can interrupt your sleep cycles. Now, some examples of observational studies are if you sample some people with and without pets to see differences in happiness, or you would analyze cars in a busy intersection to try and understand traffic patterns. So the main difference is we're not taking any actions here. We're simply observing data and observing people and drawing conclusions from there. Now let's talk about samples and how to make a good sample. Now, samples are just a piece of your population that you take that you can conduct your experiments on or observe for your observational studies that should be representative of the entire population so that whenever you have your conclusions, you can try to generalize them to the population you took it from. Now, a good sample is one that you can draw reasonable conclusions from, and it has to be random, where everyone in the population has an even chance of being chosen. They also have to be representative of the entire population. So let's say you're trying to find the job satisfaction of high school teachers. You wouldn't want to include preschool teachers in that because it is not representative. Your sample should also be free of any bias. So things like convenience sampling, where you take the first 50 people, or voluntary response surveys, non-response bias, all of the things like that increase bias and therefore take away from the validity of your results. Let's take a look at this example question. A retail company has 50 stores located in different cities throughout the state. A researcher is believing that employee job satisfaction varies by store. Which sampling method is most appropriate to estimate the proportion of all employees of the company who are satisfied with their job? Alright, so let's just take a look at each of the answer choices and see which one makes the most sense. So this first one, this one is wrong because we are only selecting one store, which is not representative of the entire population. So let's go ahead and move on to answer choice B. This is where we select 10 employees from each store and then randomly survey them. So this does sound correct because it is representative, as we are selecting employees from each store and they're being selected at random, all of the employees. So this sounds like it is randomized and it is representative. So let's move on to answer choice C. This is where we survey the highest and the lowest paid. So this is not random because we know who the highest and lowest paid are, nor is it representative of those who aren't in that range. Now, this last one is about creating a website. So this already sounds like a convenience sample because it is saying that we're going to take the first people who respond to our survey, which is biased. So this means the best answer choice for this situation is B. Now, a lot of SAT math questions of this topic will make you derive a conclusion based on a description of the study or experiment. So here are some things that you should think about. Sometimes you're given an estimate and a margin of error. So this forms a range estimate that the study believes is a plausible conclusion for the population. You should also think about the sample. So this was the stuff we were talking about earlier, like is it random, is it biased, how representative is it, things like that. This will allow you to make a better judgment with the conclusion. And finally, your results should apply to the population from which the sample was derived from. So if your experiment was about 18 to 25-year-olds from Texas, you shouldn't be thinking about people who are age 30 in Canada. Now let's take a look at another example question. A researcher surveyed a random sample of students from a university about how often they see movies. Using the data, the researcher estimated that 23% of the students in the population saw a movie at least once per month, with a margin of error of 4%. Which is the best conclusion? So our margin of error is 4%. So that means we would take plus or minus 4% of our original estimate of 23%. So that means our margin would be between 19 and 27%. So let's take a look at each of these answer choices. The first one says that it's unlikely to be less than 23, which is incorrect because some numbers under 23 are still included in our range. Moving on to answer choice B, at least 23 but no more than 25. That is still wrong because 26 and 27 are included in our range. The next one is answer choice C that says the researcher is between 19 and 27% sure, which sounds more like a confidence interval and not really a margin of error. So let's move on to answer choice D. It is plausible that the percentage of students who see a movie at least once per month is between 19 and 27%. So this describes what a margin of error is, and it has the correct range. So answer choice D is correct. All right, let's take a look at one more example. A market researcher selected 200 people at random from a group of people who indicated that they liked a book. The 200 people were shown a movie based on the book, and they were asked whether they liked or disliked the movie. So of the ones that were surveyed, 95% say they didn't like it. So now we need to figure out which conclusion can be drawn. The first one, at least 95% of people who go see movies. This one is wrong because it is making a conclusion about the wrong population. Remember, the research was only conducted on people who read and liked the book, not everyone who watches movies in general. The next one, 95% of people who read books will dislike the movie. So this is also wrong for the same reason that A is wrong, because it is the wrong population. The next one, most people who dislike this book will like the movie. So the study suggests that people who liked the book disliked the movie, not the other way around. That means that answer choice D is the correct answer. And that's all I wanted to cover in this video. Thank you so much for watching, and I hope you learned something new and are now ready to kill it on the SAT math section. For more practice problems and access to a 24/7 online study tool, check out AceIt at the link below. AceIt is the ultimate study tool for the SATs and the ACTs created by Juni Learning, an award-winning educational tech company that has helped thousands of students take their learning to the next level. Get a free trial when you use the link in the description. Until next time, and good luck studying!